So today I'm going to be talking to you guys about bisphenol A and if it's a potentially serious health threat, or if there's concern to or need to be concerned about BPA and its prevalence in the making of a variety of plastics. So bisphenol A and why it may be potentially a health concern is because it's in a variety of food storage containers. It's used in the manufacture of polycarbonate plastics. It's used in protective linings of food, dental sealants, and many other products that are made of some kind of sturdy plastic. It's been used. It's cheap to make, and I think that's why a lot of manufacturers and companies use it as well. The sources of bisphenol A is, as I kind of already stated, beverage containers, compact discs, plastic dinnerware, the impact safety resistant equipment, automobile parts, and toys, various toys manufactured for children. So currently, the potential toxicity of BPA, it's been examined extensively with numerous safety studies conducted over more than 40 years. These studies have shown that the toxicity of BPA is low, as assessed to standard test protocols. So exposure evaluations have demonstrated a large margin of safety between exposure levels of BPA and the level of concern. So with these together, these tests and evaluations demonstrate that consumer exposure to BPA does not pose a risk to human health. So that's really what a lot of the studies, that's a general overview of what they're showing. There's been a hypothesis that has evolved in the recent years, and it claims that exposure to extremely low doses of certain substances could cause adverse health effects in humans, including the disruption of hormonal functions, which is basically saying that BPA is an endocrine disruptor and disrupts the endocrine system. So the hypothesis is limited, though, regarding its cause and effect, and it has not been confirmed through repeated experimental tests. So just to reiterate, this low dose hypothesis basically is stating that health effects occur at doses which are far below levels that were previously determined to be safe. And this is compared to using well-established toxicological procedures. The hypothesis also states that the dose-response relationship for these substances is non-monotonic. So this basically just means that health effects may only be observed at low doses, while much higher doses result in no effects. So the claimed non-monotonic dose-response relationship is completely contrary. It's very counterintuitive to the fundamental principle of toxicology, which states that the dose is basically what becomes the poison. The low dose hypothesis that has been proposed recently, it's largely based off of small scale studies that these studies have reported that reproductive and developmental effects in mice and rats from low doses of BPA are affected by BPA, their developmental and reproductive capabilities. So attempts to confirm this hypothesis by repeating these initial experiments have shown that results cannot be replicated, which indicates that the hypothesis then wouldn't be valid. more importantly, large-scale experiments using accepted protocols have found no evidence for reproductive or developmental effects from low-dose BPA. So a large number of separate scientific bodies, after reviewing all of the evidence, have concluded that the low-dose hypothesis is unproven at this point, and doesn't apply. So currently, that's the thought on the low-dose hypothesis. So kind of as stated before, the dose-response assessment relationship between dose and occurrence of health effects in humans, there has been nothing confirmed on this, neither on large nor small scale. So it's still under study and investigation. The exposure assessment, just to kind of talk about some of the studies that have been done, there's been some popular large-scale studies, but these large-scale studies ultimately didn't show anything. So there was a 3-generation study conducted by the Research Triangle Institute, and in this study, they used spray dolly rats, and they were fed a diet containing BPA at levels that ranged from 0 to 7,500 parts per million, which would yield a variety of intakes. These exposures were basically continued until adulthood of the 3rd generation. The endpoints that were evaluated were parental growth rate, food intake, reproductive performance, sperm production and motility, gross and histopathology, organ weights, litter size, pup survival, and growth. And they also measured the anogenital distance. The analysis of this data for all of these endpoints for parental and the 3 offspring generations ended up revealing that no evidence of a low-dose effect of BPA was exhibited. So it was a powerful study, which it complied with good laboratory practice standards, but clearly also demonstrated that there was an absence of low-dose effects for BPA. This study was particularly reevaluated as part of an independent scientific peer-reviewed effort of the evidence for and against low-dose endocrine receptor effects, and this was organized by the U.S. National Toxicology Program. So during this peer review, they included a statistics subpanel that reevaluated the experimental design, data analysis, interpretation of the results of the study claiming low-dose effects, as well as studies that found no evidence of low-dose effects. That was the Research Triangle study. And there was another study, actually, that was done by the Chemical Compound and Safety Research Institute in conjunction with the Japanese Institute of Health Sciences. So in this study, which was also a large-scale study, they used IGS rats, and they were dosed orally by stomach tube over 2 generations. There was a variety of doses applied. The endpoints assessed performance, sperm production, motility, gross and histopathology, organ weights, litter size, pup survival, and growth, and also the anogenital distance. The study also measured reflex development, maze performance, and several hormones that are related to reproduction. So the analysis of data for all the generations revealed that there was no evidence of low-dose effect of BPA, which is also consistent with the results of the Research Institute Triangle study. So that was large-scale studies. The small-scale studies have shown, they have contrasted the two large-scale studies. So in the small-scale studies, there's a particular study that has been done at the University of Missouri, and this study reported that there was an increase in prostate weight in the male offspring of mice that were exposed to BPA during pregnancy at 2 and 20 micrograms to kilograms of body weight a day. The study only included those 7 females per treatment group and 11 unexposed controls, and only 1 male from each litter was examined. So basically, they used a small sample size. They did show that the pre-pituitary gland weight was reported to be increased, but although the seminal vesicle and testes weights were unaffected. So the 20 microgram to kilogram body weight a day dose was associated with a 20% reduction in daily sperm production per gram of the testes weight, but the dose had no statistically significant effect on body pre-pituitary, epididymal, seminal vesicle, or testes weight. So these parameters were all assessed in the same individual males per litter as well, and were used in the first report by only 5 males per BPA treatment group, and 8 control males were used for the sperm production test. So, this is small, and there's not a lot of, the sample size is incredibly small. There were also 2 independent larger scale studies done subsequently at the University of Missouri to test conditions to determine if reported results could be replicated. These results that were done at the University of Missouri originally, they couldn't be replicated on large-scale studies. So in both cases, the reported low-dose effects weren't replicated, so therefore there was nothing really meaningful that came out of them. A study that was sponsored by the Society of Plastics Industry and carried out by the European Chemical Industry Council also was another small-scale study. So they attempted to duplicate the original experimental conditions by the University of Missouri, and what they did is they found that they tried to replicate the study. They employed more doses and more mice per group. The female treatment group and the controls and all male offspring, and had a greater number, and they also applied a greater number of endpoints than the original studies. And they found that no low dose effects were observed. So, the problem is that they cannot reproduce on a large scale the exposure to BPA, even at low doses, if it has caused any health effects. The risk characterization of BPA, there was an interesting survey done by the CDC, and the survey, it's called the 4th National Report on Human Exposure to Environmental Chemicals, and this was done during the 2003-2004 years. The CDC scientists measured BPA concentration in the urine of 2,517 participants aged 6 years and older who took this survey, and they did show that there was a widespread of BPA in all of the participants, not necessarily a high concentration, but that all of them contained this, and but they didn't show that there was any adverse health effects related to people having BPA in their urine. The people didn't show any increased susceptibility to any adverse health conditions. So currently, with the risk management of BPA, the options are sort of limited. There's been nothing proven to show that BPA is an endocrine receptor antagonist or disruptor, except for on the small scale experiments in animal models, but these have not been shown in human models. So the current tactic that should be used, and that has been suggested by FDA, CDC, other organizations been looking at BPA, is that if people are concerned, is to buy containers and plastics that are BPA free, which they do sell in stores. So that would be the best approach. Particularly, there has been conversation about baby bottles, and a lot of baby bottles have been made with BPA. And so, just as an extra level of safety, it is probably best to avoid giving your children baby bottles that contain BPA. Their systems are rapidly developing, and they cannot fend off potential mutations and various things that possibly BPA could cause, although it's probably a small chance based off the studies that have been done. The future work really needs to focus on having strong small-scale studies that can actually be converted to large-scale studies. The BPA in small-scale studies is great if it shows that there's been reproductive adverse health conditions. But if this can't be reduced on a large-scale measure, then it's not worth anything. There's no significance to it. Another thing that is a flaw in the work is, these studies have been done in only animal models. There hasn't been tons of attempt to produce large-scale studies of people who have been followed for a long time to see if BPA affects them from from infancy to childhood to adulthood, or just adulthood, or just infancy, or the developmental process. Many of these things are all in animal models, so we don't have anything to really go off of. The last slide that I was just going to show you is kind of interesting, but I did find, and I provided the website at the bottom, but that cash register receipts that you get at the store, apparently they contain a significant amount of BPA. And so, regardless of if this is actually true or not, the BPA can be an endocrine disruptor. Might be something to pay attention to. So I just read the process up here and thought it was really interesting. So that'll conclude my lecture on BPA. And overall, it's a controversial topic. There's been nothing that's been proven to show that BPA is a definite concern for causing adverse health effects. So more work needs to be done. And thank you for listening today.